All right, this video is going to debrief the activity called Can You Guess the Correlation? All right, so we've got 6 scatter plots here, and below each one is what's called a correlation value. And so we're trying to kind of figure out, um, just by observation, what is this number measuring? What is this number telling us about each scatter plot? So one thing your group might have come up with is the correlation is telling us how closely the points follow a line, right? You can see like in this one here, right, the points fall pretty closely to a line, and the value here is pretty close to 1. Whereas this one is very random looking. It's hard to even tell whether the points are forming an upward trending line or a downward trending line. And you can see that the correlation value is close to 0. Okay. In fact, any scatter plot where the points are trending upwards has a positive correlation, and any scatter plot where the points are trending downward has a negative correlation. Okay. So not only does it tell us kind of how closely the points are to a line, in that sense, it kind of is describing the strength of the relationship, but the sign, positive or negative, also indicates the direction. So we're going to add that in as a note here next to question 1. Okay. So the number is telling us the strength of the linear relationship. Okay. The closer to 1, the stronger. The closer to 0, the weaker. Okay. And then also the sign is telling us the direction of the relationship. Positive sign, trending upwards. Negative sign, trending downward. All right, let's add some verbal descriptions next to each of these scatter plots. So for the first one, we could describe this as a fairly strong positive relationship. All right, top middle would be like a moderate negative relationship. Okay. All right, this one is very strong and in the negative direction. Right. Bottom left, it's kind of a weak relationship, but we can kind of tell that it's headed in a positive direction. Positive. This fifth one, right? It's really hard to see any sort of trend whatsoever. So we would describe this as having almost no correlation. Right? And that's kind of the reason why the value is so close to 0. All right, the last one here, we can probably describe this as being moderate and in the negative direction. Okay, next, you were given a couple new scatter plots and asked to pick out the direction, positive or negative. Pick a word to describe the strength, so anywhere from weak to very strong, and then to try to quantify that with a number. So for this scatter plot here, we would describe it as positive. The points are trending upward. Moderate, they're not too random looking, but they're not super tightly aligned either. And so a good guess might be a correlation of positive 0.5. The actual correlation for that scatter plot is 0.551. Okay, so I should label this R equals 0.551. Right. So if you guess somewhere around 0.5, that's actually a pretty good guess, 0.5 to 0.6. Okay, question number 3, this last scatter plot, it's pretty clear that this is going in the negative direction. The points are very tightly aligned, so we would describe it as very strong, and the number we might use is something close to -1, but not exactly. The points aren't perfectly aligned. So negative 0.97 might be a reasonable guess. The actual correlation for this scatter plot is negative 0.991. 4. Okay? It is very, very close to -1. All right. I want you to pause the video here and then work on page 2. Okay. So on page 2, you're going to be writing some interpretation. So interpreting this correlation value, as well as another measurement called the coefficient of determination. Right. So after all the groups are finished with page 2, you can unpause the video and see the rest of this debrief. Okay, so I'm assuming that you finished page 2, and let's go ahead and debrief it now. So in question 4, we want to kind of describe how the correlation would change if we add a new point to the scatter plot. Now notice that this point follows the already existing trend or pattern. Actually, we should probably make a note of that. Or in other words, it is aligned with the already existing points. Okay? So because it is aligned with the other points, it's going to strengthen the correlation, or we can say that the correlation will get closer to +1. Okay? The data with that point is actually more linear than it was before the point was added. In the next graph, now the point that was added, or that was changed actually, doesn't really fit in with the linear trend anymore. You can think of it as an outlier. Okay, and so let's make a note. This does not follow the linear pattern. So because it is out of alignment with the other points, it's going to now weaken the correlation. It's going to make the correlation drop down and get a little bit closer to 0. All right. So points that are aligned with the others will increase the correlation. Points that are misaligned with the other data points will weaken the correlation. Okay. Question 6 and 7 provided you with some template sentences for writing some interpretations. So the first thing that we want to interpret is the correlation value itself. And so what you need in your interpretation is context, so what's the explanatory and response variable, okay? Some sort of word that describes the strength, so it could be weak, moderate, strong, very strong, and then the direction, either positive or negative. Okay, so the correlation, the R value was right here, 0.987, so let's write it, 0.987. Okay. So that's positive for 1. So notice the word positive in our sentence. It's close to 1. It's really close to 1. So notice the phrase very strong. Okay? And then, of course, the context, number of rubber bands, and distance traveled. So altogether, the linear relationship between number of rubber bands and distance traveled is very strong and positive. Right. The second value that we're interpreting here is represented with the notation R squared, and it's called the coefficient of determination. Okay. I'm not even sure where that name comes from. I don't think it even does a good job describing what it is it's measuring. But the sentence, I think, does a good job of describing what this number means. So R squared, you want to think of it as a percentage of the variability in the response that is explained by the explanatory variable. So the closer it is to 100%, the better the explanatory variable does at explaining away the variation in the y values. All right, so let's go get that R squared value. It's 0.974. And if you're curious, yes, that is what you would get if you take 0.987 and square it. You would get that number. Okay, so there's a direct quadratic relationship, I guess you could say, between R and R squared. I forgot the number already, 974. R squared is 0.974. Okay, so we could say 97.4%. So this is really a proportion multiplied by 100 to make it a percentage. 97.4% of the variation in distance traveled, that's the response variable, is explained by the linear relationship with number of rubber bands. That's the explanatory variable. So you're really just going to take the template and change 1, 2, 3 things in it, depending on, the context and the value that you have. All right, last page now. We'll do the quick notes, and then you guys will have a chance to check your understanding on a new set of problems. All right, correlation. First of all, it measures 2 things, right? It measures the direction, again, either positive or negative. Positive or negative. It measures the strength, so it's going to be some number between -1 and +1. Okay, both of those extremes are very strong relationships. A value close to 0 indicates a weak relationship. And then here's probably the most important thing. Okay, the correlation is only used to measure linear relationships. You should never use correlation to describe nonlinear relationships. So if you had a quadratic looking scatter plot or an exponential looking scatter plot, just correlation is throw it out the window. Don't use it. It's really only meant to describe linear relationships. All right, here's that template for writing your interpretation. The linear relationship between X and Y, right, explanatory and response, is, right, then you're going to fill in a word for strength, weak, moderate, strong, very strong, and then you'll fill in a word here for the direction, either positive or negative. All right, coefficient of determination. All right, we're just talking about this. There's 3 things that you need to input into this template. The value of R squared, which you're going to write as a percentage, okay, the response variable and the explanatory variable. Okay. So about R squared percent of the variation in Y, the response variable, is explained by the linear relationship with X, the explanatory variable. Okay, this last thing was not part of the activity, but it's a very important topic. Just because 2 variables have a strong correlation does not mean that one variable causes the other. Classic example, there's a strong correlation between the number of ice cream sales in a given month and the number of drownings in the same month. The correlation, I don't know the exact value, but it's pretty strong, like 0.7, 0.8, something like that. And so that might lead one to believe like, oh, maybe we shouldn't be selling ice cream to people because, maybe they're like cramping up and drowning when they go swimming. Okay, but that's not really the case at all. The reason for the correlation has to do with a third variable, which is the time of year. Right? So summer months, right? People are buying a lot of ice cream, but they're also going to the beach, going to, the community pool, going to water parks. And so naturally there's just more, by sheer numbers, more opportunities for people to drown. Compared to like winter months, okay, when it's cold, people aren't, buying a lot of ice cream and they're not going out to the beach and to the pools as much either. Okay. So 2 variables can be strongly correlated, yet not have a cause and effect relationship with one another. Okay, I think you're actually going to look at an example of that in the check your understanding question. So I'm going to end this video here. You guys can work on this check your understanding question, and then I will see you all next class.